This is lesson 931, problem 966. In this problem, we're going to look at what is different about the graphs of this equation and this inequality I have written here. So first, we're going to graph the equation y equals negative 2x plus 3. So remember, when we are graphing lines, right, y equals mx plus b, we start with the plus b part. So the plus 3, so I'm going to go up to 3 on my y-axis. It's my starting point, my y-intercept. And then my slope is negative 2, and I remember I can always write that as negative 2 over 1. So from where I started, from my y-intercept, I'm going to go down 2 and over 1. So down 2 in the negative direction, over 1 in the positive direction, down 2, over 1. And I can keep doing that. And I could also reverse it. Instead of going down 2, I could go up 2 and then over 1 to the left. All right, once we have that, we can draw our line through our points. Okay, so now that's the equation y equals negative 2x plus 3. And so the only points that are going to make this equation true would be the points that we see on our line. So if we were to pick any point on our line, I'm going to pick this point here. That's the point 1, 1. And I'm going to substitute that in to, oops, sorry, I'm having technical difficulties writing this out here. I'm going to substitute that point that was on my line, the point 1, 1, into my equation and see what happens. So y is 1, and x is also 1. And I'm going to see what happens when I solve. I get that 1 equals 1, okay, which is a true statement. So any point on my line that I pick, so this point, any point that's on that line, when we substitute those into our equation, they are going to make the equation true. So the left side will equal the right side. And that will only happen with points that are on our line. All right, so now we're going to take a look at the inequality there. Okay, so now we want to graph the solutions to the inequality that of y is greater than or equal to negative 2x plus 3. So our question is, how is this going to look different? How will our graph look when we're graphing the inequality? So what I'm going to do is I'm going to test a point that is not on my line. Okay, so I'm going to test a point that's either below or above my line. A good point to test, because you get nice numbers and you get things to go away, is the point 0, 0. So as long as that's not on your line, that's a nice point to pick to substitute into your inequality. So I'm going to look at my inequality now, and I want to test the point 0, 0 and see what happens. So I'm putting 0 in for y. So I have 0 is greater than or equal to negative 2 times x. Well, my x is also 0. And then I have plus 3. So if I keep solving, I get that 0 is greater than or equal to, let's see, negative 2 times 0 is 0, plus 3. And if I simplify, I have 0 is greater than or equal to 3. So 0 is greater than or equal to 3 is not a true statement because 0 is less than 3. So that's not a true statement. So that means that that point, 0, 0, is not a solution to my inequality. Okay? So that way, so I know that none of my solutions for this inequality are going to be below my line. Since 0, 0 did not give me, make this a true statement, that must mean that my solutions are all above my line. Okay, so I'm going to just check that. So I'm going to pick a point above my line. Let's go with this point. I can pick any point, that point there. Let's go with the point 3, 1, and we're going to check it. So I have my same inequality, and I'm going to substitute in 1 for y, 3 for x, and solve. And I get that 1 is greater than or equal to -3. That is a true statement. So that means that point was above my line here, so that means that any point I pick above my line is going to make my inequality true. So to show that, what I want to do is I want to highlight all of the points that are above my line. And notice when I tested that point that was below my line, 0, 0, that didn't make them true, so none of those points below my line will make my inequality true. Okay, so it'd be everything above my line. And then because our inequality has the equal sign underneath it, okay, so that means that all of the points above my line, so that we're greater than my line, make it true, and because the equal sign is there, all the points on my line are also true, okay? And I show that by making my line solid, all right? And we'll look at another problem next where we have one that is not greater than or equal to. It might be just greater than, and we'll look at that and see what happens in that situation. All right, so when we look at this again, the points that make this inequality true are the points that are either on the line or above the line, okay? And that means I have an infinite number of solutions because it's all of those points. It keeps going even off of my page here. So this inequality has an infinite number of solutions.